17th, 2026. Currently 5:03 in the afternoon. 5:03 in the afternoon. Let's go sign in to all my different accounts. Go. Set up over here. Set up on Twitch and YouTube. Everything, stream has started. Very good. And let me go ahead and sign into my account over here. Come on. See, there we go. View channel. All right. Signed in there. Hello, hello. There we go. There we go. Come on. All right, so we're signed in there. Go home, go to my profile, and we're set. All right, so what's the stream about? The stream is as it's written at the beginning. It is the Copywork using Gregg Shorthand, and we're using this to review. We're using this to review the process of arithmetic, algebra, trigonometry, all aspects of mathematics. It's a way to do a little bit of a mental review in preparation for continued advancement of studies, and I'm using a more esoteric methodology or a more esoteric tool in order to engage with the material, and that is Gregg Shorthand. The purpose for Gregg Shorthand is to be able to capture ideas and thoughts with a reduction in the amount of physical effort. You can therefore go more quickly and also have a more accurate understanding of your information. So the stream, as you see, testing 1, 2, 3. Hopefully it's coming through. Let me check. Come on. Just we need to check the sound. Therefore go more quickly. Good. All right, so sound is good. Everything's ready to go. So the book that I'm using is the textbook by Augustus De Morgan, The Elements of Arithmetic, and don't let that fool you. So this book was written in the 1830s, or it was published in the 1830s, and in many ways, this is not just a book on arithmetic, it is a primer on algebra as well. It's the beginning algebraic concepts. We've already dealt with things such as the product of terms, the product of binomials. We're currently going into using more of an algebraic or symbolic understanding of numbers. So definitely an excellent primer and well worth the effort to go through. So we'll continue working as we go. Currently in section 4, that's the meaning of the heading, Elements of Arithmetic, section 4, and this is page 2 of this particular document. So let's go. Okay, so we're looking at paragraph number 74, and currently on, we were just looking at the possibility of adding another form to the dictionary, and that was as far as, I believe, or as often as, and so for that it was going to be SO, essentially the same word as soften. So if we go as often as, okay, all its parts together. It is plain that 156 contains 13 as often as all its parts together. As often as all its parts together. Okay. For example, 156 is made up of 91. 156 56 is made up of made up of 91, 39, and 26. Period. Of these, 91 contains 13 7 times. Comma. 39 contains 13 3 times. 39 contains 13 3 times. And 26 contains 13 2 times. And that's semicolon. We begin the new section, new paragraph. Therefore, 91 plus 39 plus 26 contains 13 7 plus 3 plus 2 times. 7 plus 3 plus 2 times, or 12 times. Again, here's a new paragraph. Again, 156 is made up of is made up of 100, 50, and 6. Okay. Now, 100 contains 13 7 times. Now, 100, so this is a new paragraph here. Now, 100 contains 13 7 times. And how many over? Let's see, that's not quite marked, but I think, is it 9 over, right? Because 7 times 13 is going to be 7, it's 91, and then, yeah, 9 left over to make 100, and 9 over, comma. 50 contains 13, 50 contains 13 3 times, and 11 over, comma. 6 contains 13 0 times. 6 contains 13 0 times, and 6 over. Therefore, 100 plus 50 plus 6 contains 13, 7, 7 plus 3 plus 0 times, and 9 plus 11 plus 6 over. Or 156 contains 13 10 times. And 26 over. But 26 is itself 2 13s. Therefore, 156 contains 10 13s. And 2 13s. Or 12 13s. That was the end of Article 74, so now I'm going to go back through and reread that. If I divide 156 into several parts and find how often 13 is contained in each of them, we check each. That's each. In each of them, it is plain that 156 contains 13 as often as all its parts together. For example, let's go ahead and fix for example a little bit here. For example, 156 is made up of 91, 39, and 26. Of these, 91 contains 13 7 times. 39 contains 13 3 times. 26 contains 13 2 times. Therefore, 91 plus 39 plus 26 contains 13 7 plus 3 plus 2 times, or 12 times. Again, 156 is made up of 150 and 6. 100 contains 13 7 times and 9 over. 50 contains 13 3 times and 11 over. 6 contains 13 0 times and 6 over. Therefore, 100 plus 50 plus 6 contains 13 7 plus 3 plus 0 times and 9 plus 13 plus 6 over. Or 156 contains 13 10 times and 26 over, but 26 is itself. Let's go ahead and fix itself. Curves under like that and then around. It's a beautiful little form. Itself 2 13s. Therefore, 156 contains 10 13s and 2 13s, or 12 13s. And then we move on to Article 75. The result of the last article. Is expressed by saying let's see what expressed is. Very good. By saying that if A equals B plus C plus D, then, we'll do this on a new line, then the ratio of A to M is equal to the ratio of B to M plus C to M plus D to M, like so. The ratio of A to M is equal to the ratio of B to M, C to M, and D to M, or, simply put, we are dealing with the division, that the division of A by M is equal to the sum of each of the components divided by M. And that's essentially, that is 75. It is very important to remember that in the context of ratios. So the sum of ratios, if the parts are equal to the sum of the whole, then the ratio of the parts, if you are dividing them each into components, will also be equal to the whole. Can have a lot of use, especially in algebraic examples. Moving on, 76. Actually, let's see, do I have to read back over? We did 74 already. So the result of the last article, it's so short, I'm not going to read over it. Let's go ahead and move forward to 76. Scrolling down the line, new page actually. Elements of Arithmetic. Section 4, page number 4. Beautiful. All right, so we go back up. New paragraph marker, and this is 76. Okay. we begin. In the first example, I did not take away 13 more. I did not. Oh, and did not requires a circle at the top. Take away 13 more. Then once at a time. Now, at a time, isn't there a phrase for that? Yes, I thought so. At time, yes. So, that's my form. I'm the one who put it in there. So, I guess it's legitimate. But what it is, it just does a slight jag at time for at a time. So if you do a slight jag in the line, allows you to do the whole thing. So there's at a time. I did not take away 13 more than once at a time, comma, in order that the method might be as simple as possible. As simple as. There's another as simple as. There are a lot of phrases like that where you can combine as simple as, like so. Possible. Period. But if I know what is twice 13, three times 13, etc. I can take away as many 13s at a time at a time as I please. If I take care to mark at each step. At each step. How many I take away. For example, comma, take away 13 tens, take away 13 10 times, at once from 156, comma, that is, take away 130, comma, and afterwards take away 13 twice. Or take away 26. Comma, and the process is as follows. Is as, remember, is as or as is can both be shown by this. Semicolon. 156, and so we'll actually show this here. Maybe we'll use half boxes for this. 156 minus 130, which is, of course, 10 times, which of course is 10 times 13, and we then subtract, leaving us with 26. And then we have 26, which is 2 times 13, which then subtracted renders us with 0. Therefore, 156 contains 13. 10 plus 2, or 12 times. And then he gives another example here, again to divide 3096, new paragraph marker by the way, again to divide 3096. 96 by 18 you would have to go through that whole process right there, which I'm not going to, but it would be 100 times 18, 50 times 18, 20 times 18, and 2 times. So if you followed that whole structure out, then you would get the result, but I'm just going to write the paragraph here, which states, therefore, 3096 contains 18 100 plus 50 plus 20 plus 2, or 172 times. And there we go. Okay. 172 times. And so that one would be our answer. Okay. Moving on to 77, but before we do that, let me go ahead and mark, or I'm going to go back and reread any parts of 76 that we needed to work through. There we go. There's 76. Grab a little bit of water first. Let's begin. In the first example, I did not take away more than once at a time, in order that the method might be as simple as possible. But if I know, and let me fix that no just a little bit. There we go. If I know what is twice 13, 3 times 13, etc., I can take away as many 13 should be 13s, at a time as I please, if I take care to mark at each step how many. Let's fix that many a little bit. Needs a little bit more predominant of an E. How many I take away. For example, take away 13 10 times at once from 156. That is, take away 130, and hold on, this is the one that's after. That's after, in which case the F needs to be a little bit more pronounced. That's what that's doing, afterward. Yes, we'll curve it forward just a little more. And afterwards, take away 13 twice, or take away 26, and the process is as follows. Let's go ahead and fix is as, make it almost looks like a 3, so we just need to do a curve for is as follows. And then we lay this out, and we end up with 156. If you subtract 130, that's 10 times 13, you're left with 26, and then you subtract 2 times 13, you're left with 0. Therefore, 156 contains 13, 10 plus 2, or 12 times. Okay, and then of course it gives the example for, again, to divide 3096 by 81 by 18. You went through the whole process laid out here in the verticality. Okay, the verticality is going to show you that process by which you extract key portions of 18, or multiples of 18 as it's called. And if you do that whole process, therefore 3096 contains 18, 100 plus 50 plus 20 plus 2, or 172 times. Okay, so you're always trying to find the most multiples of a value. Okay, moving on to paragraph or article 77. You will now understand the following sentences. Here we go. You will now understand the following sentences, and be able to make similar assertions, and be able to make similar assertions. Assertion, I think that, is that AS, and then wasn't it the, it goes shun, something like that? Let's go check. Curves backwards. Assertions. Okay. Similar assertions. Very nice. Of other numbers. Of other numbers. For example, our next line down, 450 is 75 times 6. Semicolon. It therefore contains any number as 6 times as often as 75 contains it. It therefore contains any number as 5. In other words, it's talking about the multiples, right? As 5. 6 times as often as 75 contains it. 6 times as often as 75 contains it. Period. Okay. And then it says contains, right? So 135 twice contains 3, 26, so on and so forth. 472 contains 18 more than 21 times, therefore 472, so on and so forth. It's just laying out all the different examples of multiples, okay? So all of those, this whole table right here is talking about multiples, okay? And we're going to skip all that. Let's go straight to 77 or to 78. And 78 says, or it states, the foregoing articles contain the principles of division. The foregoing articles contain the principles of division. Period. The question now is, comma, to apply them in the shortest and most convenient way. Check convenient. Also need to check shortest. Check convenient. Correct. No need for the int though, just in. Shortest and most convenient way. Period. Suppose it required to divide 4068. Suppose it required to divide 4068 by 18, or to find 4068 by 18, or to find, and then we lay this out in the fractional form, correct? 4068 by 18. And that's according to paragraph number 23, or article 23. New paragraph. Not going to bother marking it. If we divide 4068, if we divide 4068 into any number of parts, comma, we may by the process followed in Article 74. We may, by the process followed in Article 74, find how many times $18 is contained in each of these parts. Comma, and from thence how many times it is contained in the whole. And from, thence. We've done thence before, I'm pretty sure. Isn't it this one right here? Let's check thence. Nope, curves the other way. Curves the other way. And from thence, how many times it is contained in the whole. Period. Now, what separation of 4068 into parts will be the most convenient? Observe that 4 go ahead and add another page below. Observe that 4, comma, the first figure of 4068 does not contain 18. but that 40 the first and second figures together. Does contain 18 more than twice. But less than 3 times. Okay, what's his little note there? The bottom. If you have any doubt to this expression, recollect that it means contains more than 2 18s, but not so much as 3. Okay, so it's giving a range. That's what he's talking about. Okay? Does not contain 18 more than twice, but less than 3 times. The first and second figures together does contain 18 more than twice, but less than 3 times. And that one was underlined through does contain, or starting at does contain. So we'll underline that whole thing going on. But 4068 is made up, and this is according to Article 20. Interesting. Article 20 is made up of 40 hundreds. Okay. It's talking about place value. Made up of 40 hundreds is made up of 40 hundreds and 68 and 68 semicolon, of which 40 hundreds according to Article 77 contains 18 more than 200 times. Semicolon. And less than 300 times. Let me check less. I always forget if that has an E or not. Yes. Period. Therefore, 4068 also contains more than 200 times. contains 4,000, of which contains, therefore, also contains more than 200 times 18, more than 200 times 18, since it must contain 18, since it must contain 18 more times than 4,000 does. It also contains 18 less than 300 times. Because 300 times 18 is 5,400. A greater number than 4,068. That is, comma, subtract 3,600 comma, and there remains 468. There remains, yep, and there remains 468. Therefore, 4,068 contains 18 200 times. And as many more times as 468, and as many as, and as many more times, and as many more times as 468 contains 18. It remains then to find how many times it remains then to find how many times 468 contains 18. Proceed. Exactly as before. Let me check proceed. Exactly as before. Move up the page a little. Observe that 46 contains 18 more than twice. And less than 3 times. Therefore, 460 contains it more than 20. And less than 30. And that was according to Article 77. As it does also 468. As it does also 468. Subtract 18 20 times. From 468. That is, subtract 360. The remainder is 108. Therefore, 468 contains 18 20 times, and as many more as 108 contains it. And now, 108 is found to contain 18 6 times exactly. Therefore, 468 contains it. (20 plus 6 times). And 468 oh no, and 4068 contains it. 200 plus 20 plus 6 times. If we write down the process that has been followed, without any explanation, putting the divisor, dividend, and quotient in a line, separated by parentheses, oh, what is parentheses? That's that's interesting. I don't know if I've done parentheses before. There we go. Parentheses. Yep, pretty straightforward. It will stand as an example A. As in example A. Let it be required to divide. Oh, okay. Oh, okay, so they laid it out in A. All right, same thing. It's not necessary to show the actual mathematics here because this is a Gregg shorthand stream. So those numbers, although, I mean, if you're going to be doing the mathematics, obviously we have to do them that way. But for now, I'm not going to engage with it. I'm just going to move on and just keep on writing out the rest of the sentence, okay? So we're going to skip over the example and go straight into, as in the previous example, as in the, and then previous, previous, I believe. Yes, yes. $32,326,599. 36,326,599 is separated into $36,320,000. 30. We're going to run out of room. And 6,599. It takes the first four figures $3,632 being separated from the rest. New page. Semicolon, comma. Because it takes four figures from the left, of the dividend to make a number which is greater than the divisor. Again, 36,320,000 is found to contain 1,342 more than 20,000. And less than 30,000. Times. And 1,342 times 20,000 is subtracted from the dividend. After which the remainder is 9,486,599. The same operation is repeated again and again. Let me check again and again. Again and again that would work as a phrase. I think I'm gonna make that one G E N D G. Okay. In which case, that looks like this. Like so. Okay? Again and again. And the result is found to be that there is a quotient. To 20,000 plus 7,000 plus 60,000 plus 9 or 27,000, so we have, or 9, or, to put it together, 20,000, no, 27,000, 69, and remainder of 1. Okay. Before you proceed, so here we go. Before you proceed, comma, you should now repeat the foregoing article at length in the solution of the following questions. And we're not going to worry about that, but if we had to, we would. Before you proceed, you should now repeat the foregoing article at length in the solution of the following questions. At length. In the solution of the following questions. What are, and then dot dot, and then what I'm going to do is I'm going to I think I'm just going to say consult textbook here for that grouping right there, because remember, we're not necessarily concerned with, I'm not concerned with the mathematics. This is a Gregg, so we're dealing with the actual written, the written text. So, consult. Yeah, so consult, what is, that's consu, I believe. So we're going to do consult the textbook. And then we leave a page number so that if I ever had to go back, I would know whereabouts this was, which is page number 38. Okay, consult the textbook, page 38. All right. Good, good. Let me go ahead and see if that is consult. I believe it is consu. Yep. Consult the textbook. All right. Done. And so now we can go ahead and start in on 79, but before I do that, I need to go back and read over 78. That actually went pretty well. Let's go. There's A, as in result A. Looking back, looking back. Lots of numbers. There's 77. Article 74. Twice. There it is. Wow, that was almost a full page. That was a full page of writing. Full 2.5 pages. Okay, so here we go. 78. The foregoing articles contain the principles of division. The question now is to apply them in the shortest and most convenient way. Suppose it required to divide 4068 by 18, or to find, according to Article 23, 4068 divided by 18. If we divide 4068 into any number of parts, we may, that's a long may, wow, that's almost 3. It's a little too long. We may, getting a little carried away with myself. There we go. We may, by the process followed in Article 74, find a way, find how many times 18 is contained in each of these parts, and from thence how many times it is contained in the whole. Now, what separation of 4068 into parts will be the most convenient? Question. Observe that for the first figure of 4068 does not contain 18, but that 40, the first and second figures together, does contain 18 more than twice. But less than 3 times. But 4068, according to Article 20, is made up of 40 hundreds, and 68 of which 40 hundreds, according to Article 77, contains 18 more than 200 times and less 200 times and less. Hold on, what was I say? What was just being said? Oh. And less than what? And as many as? No. Oh, and less than 30 times. There we go. I just had to keep on reading. And less than 30 times. Had I lost a section? Article 20, Article 77 contains 18 more than 200 times. Oh, okay. And less than 300 times. That's what it was. I had forgotten a certain portion. So let's put that in here. And less than 300 times. Less than 300 times. There we go. Okay. All right. Therefore, now we can continue. Therefore, 4068 also contains more than 200 times 18, since it must contain 18 more times than 4000 does. It also contains 18 less than 300 times because, and I need that to be just a little bit more pronounced. There we go. I'm pretty sure that's because. Okay. I was right the first time. How about that? Just a little bit more of a curve. Looked a little puny. There we go. Because 300 times 18 is 5,400, a greater number. Let's make that in just a little longer. A greater number than 4068. That is, subtract 3,600, and there remains 468. Therefore, 4068 contains 18 200 times and as many more times as 468 contains 18. It remains then to find how many times 468 contains 18. Proceed exactly as before. Observe that 46 contains 18 more than twice and less than 3 times. Therefore, 460 contains it more than 20 and less than 30 times, according to Article 77. As it does also 468. As it does also 468. Hold on. Oh, where's as it does? Oi. Proceed as it does 468. Why can't I read? Let's see here. Exactly as before. Observe that 46 contains 18 more than twice and less than 3 times. Therefore, 460 contains it more than 20 and less than 30 times, according to 77. as does also, not as it. That's what was throwing me off. As does, so actually you should be able to put those together. As does. There we are. As does also 468. Subtract 1820 times from 468. That is, subtract 360, and the remainder. And the remainder, we need and. Nope, it is just the remainder. The remainder is 108. The remainder is 108. Therefore, 468 contains 1820 times, and as many more as 108 contains. Now, 108 found to, now 108 is found. Where's is? Is. Now, 108 is found. My mind is blanking. Oh, yep, there's is. Make it a little bit more pronounced so it doesn't look like a comma. There we are. Now, 108 is found to contain 18 6 times exactly. Therefore, 468 contains it 20 plus 6 times, and 4068 contains it 200 plus 20 plus 6 times. If we write down the process that has been followed without any explanation, putting the divisor, dividend, and quotient in a line, separated by parentheses, it will stand, yeah. It will stand as in example A. Now, example A, oh, come on. There we go. I'm not going to write it down, but I did say to consult the textbook, okay? So, didn't I? As in example A. As in the previous, where did I go? As in the previous example, let it be required to divide 36,326,599 by 1,342. So in that instance, did we just skip over? No, we did, as in the previous example. So I must have accidentally left out that first portion, because I did say that I wasn't going to write down the section, but I forgot to list the first portion of the paragraph. But we'll read it off here. Let it be required to divide 36,326,599 by 1,342, and that's example B. But we can go ahead and skip down over that, and now we begin in this paragraph here. As in the previous example, 36,326,599 is separated into 36,320,000 and 6,599. The first four figures, 3,632, being separated from the rest, because it takes four figures from the left. Yeah, four figures from the left of the dividend to make a number which is greater than the divisor. Again, 36,320,000 is found to contain 1,340, fix the 2, 1,342 more than 20,000 and less than 30,000 times. And 1,342 times 20,000 is subtracted from the dividend, after which the remainder is 9,486,599. The same separation of, no, the same opposition? No, operation. The same, oh, operation, and I needs an A. The same operation is repeated again and again. And the result is found to be that there is a quotient 20,000 plus 7,000 plus 60 plus 9. And let's make 9 a little less taily. There we go. Times 9. Or 27,069. And, of course, the 9 is backwards. Okay. There we go. 27,069. And a remainder of 1. Before you proceed, you should repeat the foregoing article at length in the solution. In the solution? Yes. In the solution of the following questions. What are, and then it's consult the textbook, page 38, and got no time for that. Oi. It's funny. I've got something more difficult than math at the moment, which is the shorthand. The math would be easy. But it's definitely getting faster, which is beautiful. All right, so now moving on to 79. In the examples of the last article, in the examples of the last article, observe first that, so they go first, that it is useless to write down the ciphers. That it is, oh, useless. Interesting. We've done useless. Hey, is this a first to do useless? Interesting. Okay. Nice. Always nice to be able to use more words. That it is useless to write down the ciphers which are on the right of each subtrahend. To write down the ciphers which are on the right, which are on the right of each subtrahend. Subtrahend. Have we done? I don't know if I've done subtrahend or not. Subtrahend. There we go. Oi. Comma. Provided that without them you keep each of the other figures in its proper place. Provided Good. Provided, and in this instance, yeah, you do need the disjointed D. Provided that without them you keep each of the other figures. Provided that without them you keep each of the other figures in its proper is PR. Is it PRPR or just PRP? Let me check proper. PRPR, yep. In its proper place, colon, second, that it is useless to put down the right-hand figures, that it is, another that it is useless to put down the right-hand figures of the dividend so long as they fall over ciphers. Isn't that fall? Let's go ahead and move this up, by the way. As long as they fall. No, falls the other way. Fall and follow. Okay. Let's grab a little sip of water. Okay. As long as they follow. As long as they fall. Over ciphers. Over ciphers, comma, because they do not begin to have any share in the making of the quotient. Because they do not, a little bit more curved there, because they do not begin to have any share. They do not begin to have any share is does it curve around on this side for share, or no, it's a backwards, isn't it? I think it's, isn't it that for share? Let's take a look. Share. Nope, I was right the first time. Okay. Because they do not have any share in the making of the quotient. In the making of the quotient until, comma, by continuing the process, continue. Does that continue? By continuing the process, they cease to have ciphers under them. They cease to have, to have ciphers under them. Colon. And then third, comma, that the quotient is only a number written at length. That the quotient is, can we do is only, as it would it be like that? Is only. Let's take a look at the dictionary. Is only is not there. No. There's only. So is only. That would make sense, because that's solely. Solely, right? So there's is only. Let's go to add that to the dictionary as well. I'm feeling in a dictionatorial mood. So what I'm doing is I'm getting lazy and I'm just putting all of my phrases together. But is only does work well. Okay. The quotient is only a number written at length. A number written at length, comma, instead of the usual way. Instead of the usual, that's usual, right? This way? Yeah. Instead of the usual way. Okay? Period. For example, the first quotient is 200 plus 20 plus 6 is 200 plus 20 plus 6, or 226, semicolon. The second, and these were examples, right? The second is 20,000 plus 7,000 plus 60 plus 9, comma, or, oh wait, the 6 is backwards, plus 60. There we go. So we fix that. Plus 60 plus 9, or 27,069, 27,069. Okay. Period. Strike out, therefore, all the ciphers. What if that's strike, or if it's just strk? Oh, no K, just str diphthong. There we go. Strike out, comma, therefore, comma, all ciphers okay, all the ciphers and the numbers which come above them. And the numbers which come above them. Okay. Comma. Except those in the first line. And except is, isn't it this? SEP. S-E-P. Except. There we go. Yep, S-E-P. Except those in the first line. Comma, and put the quotient in one line. Put the quotient in one line. There we go. Semicolon. And the two examples of the last article will stand thus. And the two articles of the last, oh, and the two examples, and the two examples of the last article will stand thus. Okay, and even though it says stand thus, so this is long division, right? This is the essence of long division. Like I said before, when I'm actually making the videos, I will definitely show this process because I know this trips up a lot of people. So it's good to see it laid out. It's good to do the procedure. But for right now, it's just the shorthand to get it more comfortable. So I feel I'm a broken record, but I'm just gonna state right here, open up a square bracket and say consult the textbook and page number 39. All right. Very nice. Very nice. Now, gotta put this more in the center, and I gotta go back and reread this previous paragraphical. Okay. We're gonna put a colon here after thus, and we jump back up, find the beginning of 79, which is right here. Mark it, and we start. Okay. 79. In the examples of the last article, observe first that it is useless to write down the ciphers which are on the right of each subtrahend. Provided that without them you keep each of the other figures in its proper place. Second, that it is useless to put down the right-hand figures of the dividend so long as they fall. Let's fix fall. Let's make it a little bit more grandiose. There we go. So long as they fall over ciphers, because they do not begin to have any share in the making of the quotient until by continuing the process they cease to have ciphers over them or under them. Third, that the quotient is only a number written at length, instead of the usual way. For example, the first quotient is 200 plus 20 plus 6, or 226. The second is 27,000 plus 7,000 plus 60 plus 9, or 27,069. 27,069. Strike out, therefore, all the ciphers and the numbers which come above them, except those in the first line, and put the quotient in one line, and the two examples of the last article will stand thus. And then here it says consult the textbook, page 39. Okay, and that's what we see laid out right there on the left-hand side in the Elements of Arithmetic. Let me grab a quick drink of water, and then I'm going to continue. Okay, so now we proceed. Hence, the following rule is deduced. This is the next portion. Hence, the following rule is deduced. So let's go ahead and move down the line. And time to add another page. Shift D. And this one is going to be elements. Okay. Back up to the top, and we begin Article 80. Hence, the following rule is deduced. Hence, the following rule is deduced, and this is just a long deduced, like so. Number 1. Write the divisor and the dividend in one line. And the dividend in one line. And place parentheses on each side of the dividend, period. Next paragraph, number 2, Roman numeral number 2. Take off from the left hand of the dividend the least number of figures which make a number. Which make a number greater than the divisor. Semicolon. Find what number of times the divisor is contained in these. Is contained in these, comma, and write this number as the first figure of the quotient. And write this period. Number 3. Multiply the divisor by the last mentioned figure. Comma, and subtract the product from the number which was taken off. At the left of the dividend. Period. Number 4. On the right side of the remainder, place the figure of the dividend. Which comes next after those already separated. Into. If the remainder thus increased be greater than the divisor, comma, find out how many times the divisor is contained in it. Semicolon. Put this figure at the right of the first figure of the quotient. first figure of the quotient. And repeat the process. If not on the right place, the next figure of the dividend. If not let's see here. Find out how many times and put this number on the right of the first figure and repeat the process. If not on the right place, if not on the right place of the next figure of the dividend, if not on the right place of the next figure of the dividend, and the next, and so on. Until it is the greater. But remember to place a cipher in the quotient for every figure. Of the dividend which you are obliged to take, except the first. For every figure of the dividend which you are obliged. Oh, obliged. Oh, what is obliged? Nice. OBL. Okay. Which you are obliged to take except the first. Article 5, or Section 5. Proceed in this way until all the figures of the dividend are exhausted. Proceed in this way until exhausted. Exhausted. It's a good word. are exhausted. Okay. Period. And new paragraph. In judging how often one large number is contained in another, in judging, let's put two of those together, how often one large number is contained in another, in another, comma, a first and rough guess may be made. A first and rough guess, I'm going to assume is that, but we'll go check. Oh. There's guess, and it requires an E. A first and rough guess. There we go. May be made by striking off the same number of figures from the first. First and rough guess may be made by striking off the same number of figures from both. By striking off the same number of figures from both, comma, and using the results instead of the numbers. Themselves. Thus, 4,732 is contained in 14,379 about the same number of times that 4 is contained in 14. Or about 3 times. The reason is that 4 being contained in 14 is as often as 4,000 is in 14,000. Remember, as often as 4,000 is in 14,000. And these last only differing from the proposed numbers. And these last only, differing. I think that's differing. Let me check. Oy. Yep. And these last only differing from the proposed number by lower denominations. From the, and then proposed is PR, PO, and then disjoined T. Yep. By lower denominations. Does lower have to be disjoint? No, it doesn't. But denominations, I really don't know. Oh, let's see what denominations is. Interdenominational. How about that? Denomination is not even in there. How about Okay, well, denomination is just D-M-O-M and then shun. So I will add that to the dictionary as a word. Denomination. Okay. Denomination. So let's go ahead and add that below. Zoom down the page a little. Oh, we need to add another one. And this is, boy, my eyes are crossing. Elements of Arithmetic. Section 4. Page number 8. There we go. All right, back up we go. And we continue. So denominations is going to be DM stroke, okay, and M shun. Okay, there's your denominations. Oh, wow. Well, last 28 minutes. I don't really need to adjust my camera, but hey, since I noticed. Might as well. Let's just bump up our gain here just a little bit. Yeah, no, gain's not going to help me. I think it has to be an exposure. There we go. That's good. That's good. And we'll do brightness up a little bit. Alright. Now I'm a little less in the shadow. Integrating the shadow. Okay, let's go back to work. It is interesting. Pretty much every one of the major psychologists had a shorthand. But anyway, that's beside the point. Pull up my MP3, there, or not MP3, my PDF. Okay, so denominations is this word right here. And these last only differing from the proposed numbers by lower denominations vis-a-vis, vis-a-vis. Viz. Yeah, we'll do that. Hundreds, etc. Hundreds, comma, etc. Is vis-a-vis in there? No, vizier is, but not vis-a-vis. Might as well. I mean, it's what is it? In the last 20 minutes of the video, I'm finding all the words. Vis-a-vis. I guess Augustus De Morgan developed his vocabulary as he went through the book. Okay, so we go on. Where is that? Vis-a-vis hundreds. We may expect that there will not be much difference. We may expect, and that is expect that there will not be much difference. That there will be not much difference. I will be right back. What an inopportune time. The call of nature always comes at the wrong time, I tell you. All right, so let me go ahead and switch this off. I will be back in just a minute. Alrighty, hello, back at it. So let's go ahead and get started. Switch back on over. Where were we? We were on differing? No. Much vis-a-vis hundreds. We may expect there will not be much difference between the number of times come on. Between the number of times which 14,000 contains 4,000, which 14,000 contains 4,000, and that which 14,379 and that which, no, that's interesting because that would be that one, right? That which, yeah, that which 14,000, come on, 14,379 contains 4,732. Colon. And it generally happens so. And it generally, or no, is it Jenny, right? Let's check that. Yep. And it generally happens so. Period. But if the second figure of the divisor, but if the second figure of the divisor be 5 or greater than 5, it will be more accurate to increase the first figure of the divisor by 1. It will, oh, we can do that again. It will be more accurate. Have I done that before? Aku, is it Aku? AKRA. Okay, nice. It will be more accurate to increase the first figure of the divisor to increase the first figure of the divisor by 1, comma, before trying the method just explained. just, yep, just explained. And let me check just. Good. Nothing but practice can give facility in this sort of guesswork. It's estimation. Nothing but practice can give facility to this sort of guesswork. And what was facility? Did we ever do facility? I'm pretty sure we did, but yes, it's fast, and then the disjointed L. Nice. Facility, nothing but practice can give facility in this sort of guesswork. In this sort of guesswork. Guess, and that's hyphenated. Work. Let me check guess. Dun. Oh, that's right. Yeah, we don't. It's not goose. It's guess. Guess. G-E-S. Okay. There we go. Hyphenated and guesswork. Okay. And that's the end of paragraph 80. So now I'm going to go ahead and read back over and begin 13 in, or not begin 13, begin 81 shortly. So let's go ahead and jump back to the beginning of the paragraph. This one's relatively long because it had all those parts involved with it. So we're looking for, there's 3, there's 2, there's the example, and there is paragraph 80. Let's go ahead and highlight it, and we start. Grab a little bit of water. Okay, and is that whence? Pretty sure that's whence the following rule. Hence, that's not hint, that's hence. What is whence? Just curious. Whence came. That's, yep, so it's like hence, but it has the U over the top. All right, so let's go ahead and scroll back up to number 8, and we have hence the following rule is deduced. Let's begin. Hence, the following rule is deduced. Number 1, write the divisor and the dividend in one line, and place parentheses on each side of the dividend. Number 2, take off from the left hand of the dividend the least number of figures which make a number greater than the divisor. Find what number of times the divisor is contained in these, and write this number as the figure of the quotient. Number 3, multiply the divisor by the by the last mentioned figure and subtract the product from the number which was taken off at the left of the dividend. Number 4. On the right of the remainder, place the figure of the dividend which comes in which comes next after those already separated. Hold on. Number 4. It was number 4. In two. That's what it is. Separated in 2 in step number 2. If the remainder thus increased by b greater than the divisor, find out how many times the divisor is contained in it. Put this figure at the right of the first figure of the quotient and repeat the process. If not, on the right, place apply on the right. If not, what? my mind. I can barely talk now. What is it? On the right of the what? On the right place. If not, on the right place. Oh, I did ply. Yeah, that's not right. Place. There we go. Oi. Place. No. Until it is greater. If not, on the right, place the next, figure. Place the, I wonder what I did there. Must have been looking at something else. Okay, let's go back to reading. Almost there. Place the next figure on the dividend of the dividend and the next, and so on, until it is the greater. But remember to place a cipher in the quotient. For every figure of the dividend which you are obliged to take. What's that? Obliged to take? Except the first. Number 5, proceed in this way until all the figures of the dividend are exhausted, like me. In judging how often one large is contained in another. Let me check large. Is large L-A-G or L-A-J, or is it L-J? Oh, what am I typing in? I don't know what I'm typing in. There we go. Large. Yep, that's correct. Good. In one large number is contained in another. One large number is contained in another. A first and rough guess may be made by trying off, or is it striking off? By striking off. Let me go ahead and add an S to this. There we go. By striking off the same number of figures from both. There we go. Figures from both, and using the results instead of the numbers themselves. Thus, 4,732 is contained in 14,379, above about the same number of times that 4 is contained in 14, or about 3 times. The reason is that 4 being contained, should there be a comma there? Yeah, that 4 is contained. Nope, no comma. 4 being contained in 14 as often as 4,000 is in 14,000, and these last only differing from the proposed numbers by lower. Oh, I forgot a word there. From the proposed numbers. Let's go ahead and do this a little bit more pronounced so we can see it. There we go. From the proposed numbers by lower denominations, vis-a-vis hundreds, etc., we may expect that there will be not much difference between the number of times the number of times which 14,000 contains 4,000. Oh, and I just redo. Save. Deleting stuff again. 14,000 contains 4,000, and that which, yes, and that which 14,379 contains, 14,000 contains. Man, I was just losing words left and right. Good grief. Okay, contains 4,732. And it generally happens so. But if the second figure of the divisor be 5 or greater than 5, it will be more accurate to increase the first figure of the divisor by 1 before trying the method just explained. Nothing but practice can give facility in this sort of guesswork. All right. Wow. And that's it. So I'm going to go ahead and call it there, because my time just ended. So what's it, 10 seconds, right? Something like that. Drop the volume just a hair. And there we go. So there's our time. So thank you very much for watching, everybody. And we got through a good bit. I forget the page number that we started with, but ended up on page number 40, which is great. There are about 200 pages in the book. I'm not sure exactly how many I'll end up getting to. I'm just going to keep on plugging away and just keep on keeping on. So thank you so much. I hope that you do well, and hope that your evening is blessed, and that you are endeavoring, or that you fulfilled everything that you wish to fulfill today. So thank you so much. Have a good night, and I will see you tomorrow. Goodbye.